Bismillahirrahmanirrahim. Assalamualaikum and a very good day to everyone. My name is Syazana Adilah Binti Zulkifli. I would like to present my project entitled Graphene Nanoplatelets Modify Chemlok Adhesive System for Natural Rubber Aluminum Alloy Bonding. Firstly, in introduction part, I would like to start with the background study related to engine mount. The combination of metal stability and rubber flexibility is good to use in isolated system. Adhesive system that used in the project is two-coat system, Chemlok 220 adhesive and Chemlok 205 primer. There are 4 problem statements in this study. Firstly, the existing Chemlok has insufficient bonding strength between natural rubber aluminum bond. Secondly, the introduction of nanophyllite outer structures and mechanical strength of adhesive material. Therefore, it comes to the research subject that graphene nanoplatlet GNP used as nanophyllite in adhesive due to high surface area and good thermal conductivity. Third problem statement is there are 2 limited studies on factors affecting the bonding strength of a natural rubber aluminum bond. Therefore, it is vital to study the influence of substrate condition, adhesive formulation, and process parameter. Last but not least, the agglomeration issue in nanofiller may act as a stress consideration factor and reduce the bonding strength of adhesive. Therefore, it is important to study the correlation between bonding strength and morphology of fracture surface. The objective relate to the scope. The first objective is to analyze the properties of modified graphene adhesive system at different weight percentage of GNP loading by SRD, Raman, FTIR, and DSC. Secondly, to evaluate the effect of suitable substrate condition, process parameter, and adhesive formulation by 90-degree peel test according to the STM D429 method B. And lastly, to correlate the peel strength of an RAL aluminum alloy bonded with a GNP modified Chemlok adhesive system with peel fracture surface morphology by ACM observation. In literature review part, there are 5 main keywords which are GNP as filler, Chemlok adhesive as metric, rubber metal bonding, adhesive bonding, and nano adhesive system. Table 1 show previous studies related to the nano adhesive, the mechanical properties of epoxy enhanced with small loading of graphene. Next part is methodology. This methodology part divided into part A and part B. Part A for objective 1, part B divided into stage 1, 2, and 3. Stage 1 and 2 for objective 2 and stage 3 for the objective 3. This is the process flow. It included adhesive preparation, sample preparation, hot press compression, and peel testing. Next part is to achieve objective 1 gel time test study. This is a DOE of flash time and gel time, and this is the result. The result shows that GNP loading increased the flash time and decreasing the gel time. This is due to presence of hydrophilic substance on GNP that disturb the adhesive structure. Despite from gel time, analysis is also important to achieve the objective 1. From structural analysis, SRD 002 peaks at 2 theta equal to 26.191 degree shows the presence of GNP. And from the Raman, D and G peak shows they correspond to graphitic carbon materials. Even though ID over IG ratio quite high, but is still acceptable as it is lower than 1. The compositional analysis can be seen that the Chemlok has a characteristic peak like polyurethane-based composite. Methylene character peak of GNP overlap with associated functional group at peak 2300 per centimeter wave number. And last but not least, the thermal analysis. Both TG and TM increase as the GNP increase. This proves that GNP play a good role to build path for heat dissipation. After part A done, it continue with part B1. So this DOE part B1 use an unmodified Chemlok adhesive system to achieve objective 1. The result of these studies obtained from peel strength value by the peel test. Now, this is the result from previous DOE. Peel strength increased as the aluminum roughness are reduced. For example, the sandpaper sample shows the highest peel strength value. Safari et al. 2020 also state that high RA will give poor weighting. And mechanical blasting was selected for the ease of processability and more uniform properties. Figure 8 shows that uncure natural rubber better than cured natural rubber is due to vulcanization occurring. And the effect of sweeping time shows best in 2 minute sweeping time. Too long sweeping time and dry adhesive has low surface energy and resultant in poor weighting. The DOE for part B2 same like B1, which evaluate the peel strength value from the peel test, but the sample in B2 use modified Chemlok adhesive system. Result part B2 to achieve objective 2, the effect of curing condition to adhesive strength. You can see that T-cure is better than T-room due to presence of heat and pressure that assist the adhesive load. And the figures 11 shows the effect of adhesive formulation to adhesive strength. You can see that higher GNP, the high peel strength increase. The peel strength increase at the higher GNP and drop at certain weight percent after achieve maximum value. Beyond 30 weight percent GNP, it shows that give a trivial effect to boost adhesive since both samples have same average peel strength value. And last but not least, the result part B3 is studied to achieve the objective 3. Table 8 shows almost all the sample has combination of cohesive and adhesive failure generally. Then the maximum and minimum peel strength compared from the aluminum surface. You can see in the maximum peel strength, the aluminum surface has wide area of adherent adhesive on the aluminum substrate, while the aluminum fractured surface in the minimum peel strength, lowest peel strength has almost clean with limited trace of adhesive or rubber. Let's compare the SE image between figure 11 and figure 12. Figure 11 is SE image of unmodified Chemlok. You can see that it has a smoother surface with short fibril of adhesive, shear yielding on aluminum substrate, while the figure 12 shows both surfaces showing high surface roughness and irregularities, longer fibrils from relative more ductile-like failure. So this proves that the rougher the surface, the harder to build, and it needs higher energy to split the rubber from the metal substrate. To be concluded, objective 1 achieved as analysis made shows save flash time and gel time for utilization. The structural analysis also proved that the GNP presence in the modified Chemlok adhesive system. Both TG and TM show good thermal stability. Objective 2 achieved as the mechanical blasting and cured natural rubber 2 minute sweeping time selected as suitable process parameter. Adhesive strength increased as GNP loading increased until reach certain percolation threshold at 3 weight% for the system without primer and 0.5 weight% for system with primer. The improvement in peel strength was observed to increase to about 200% with the presence of primer, and the objective 3 achieved as the bonding strength height correlated with extent of failure mode. The recommendation of this study are: first, several other dispersion techniques could be investigated. Secondly, the effect of substrate surface condition and process parameter could be further investigated. Lastly, the effect of GNP loading for narrower range of 0.1 to 3.0 weight% GNP could be investigated for further to identify more accurate percolation threshold optimize the GNP loading. This is some of the reference that I used. With that, thank you.